Hello, fans. Yeah. No, he's not telling me. Yeah, yeah. It sounds like a good one for me. All right, now. So, 2.5. Let's go through these real quick. Most of you guys can do this. This is actually really simple. So when we take the square root of -4, what do you guys get? 2. Not just 2. 2i. What is -1? 1i. What about 0? 1. 4. 9. All right. So we can graph this. Now, when you graph this, you've done this before. All right. So we are going to be graphing roots in here. But there's going to be a little more. I'm going to explain a little bit more to it because when we come back from Thanksgiving, we're going into inverses pretty quickly. Okay. So I'm going to explain kind of what we're going to do, overview of what the rest of the unit is. In this case here, we have a root. We can't draw our imaginary roots, right? Our domain for this one would be? No. What's your smallest x you have? 0. What's the largest? Infinity. So you could write this as, or you could write it as x is what? Yeah, greater or equal to 0. What about your range? Where's the bottom of this graph? Same exact thing. But as you write it as a range, you have to use what letter? The y. All right, now, when you're looking at this, some of you guys on your test screwed this up again. I'm getting the opposite. Some of you guys are writing as positive and then 0. It is the smallest to the largest every single time. Never larger to the smallest. So when you write your domain and range, check to see, A, is it from smallest to largest? Negative infinity is the smallest it can be. All right, so let's do the negative of this. So this one would be, what's the square root? -2i, -i, 0. 1 would be what? All right. So as you can tell, this one here is the underneath side of this is reflection. Your domain is, whoops, it is 0 to anything. So nothing changed there. And my range is -50 to 0. All right. So down here on the next one, we're going to put these together. You may know why we picked 0, 1, 2, 0, 1, 4, and 9. Why did we pick those numbers? Yeah, they're really nice, right? If I use 7, then you would have the square root of 7. Do you know where the square root of 7 is? I don't either, but it's somewhere between 2 and 3, so it'd be somewhere in there, right? And so it's not a nice, clean intersection on our grid. That's the reason why we picked those numbers, okay? So we're going to draw these together. Anybody know what we noticed, what we get here, guys? Almost a quadratic, right? So it does remind you of a parabola, right? Now, so a regular parabola, we would write that as y is equal to x squared, correct? And I'll draw it here on this graph right here so you can see it. Can anybody tell me what happened from the blue one to the red one? It rotated. Yeah, it did rotate it, but what values changed, I should say? Probably a better question. Not so much the graph. I know you. Beautiful that you did see that it was a rotation, basically, huh? The y's change with the what? The x's. The x's and the y's actually switch places. The equation of the red one is actually x is equal to y squared. Okay? So, as Knox was saying, we actually switched the domain and the range. All right? So when we switch a domain and range, we are actually finding the inverse. All right? So when we come back after Thanksgiving, we are going to be talking about switching your domain and range. You're switching and creating an inverse is what you're doing. Okay? So to solve the one in red here, if I was to solve this one in red for y, what would you have to do? How do I make that just a y? I'll take the square root, right? Both sides. And that will give me the square root of x is equal to y, but the absolute value of y. So y will actually equal plus or minus the square root of x. That is what the red one is. It's the square root. That's the both graphs, the positive part and the negative part together. Okay? So it's the reflection of that square root graph. All right? As you can tell, the blue graph, the domain of the blue graph is all reals, right? If I was talking about my domain, it would be all reals. My range would be from 0 to infinity, correct? You see that, Knox? Now take a look at my red one. If I look at my domain of my red one over here, what's my domain? 0 to what? Infinity. And what's my range? All real numbers. So again, I told you we were switching our domain and range. Take a look. That and that, see, that right there, that domain is now the range, and the range is now the domain. Okay? So they actually do switch locations. Okay? So domain and range is switching. So when we get back, we're going to take equations, and we're going to take the x and rewrite it as a y, and the y and rewrite it as an x, and then solve for x. Okay? So that's what we're going to be doing when we come back.